Hello students, welcome to the physics class. We are discussing the topic ray optics and optical instruments. So in the previous videos we discussed about reflection and reflection by spherical surface. So there we studied some terms related to spherical mirrors, that is focal length, radius of curvature, object distance, image distance and the image formation. So there are some of relations between these terms. So we shall look at those relations. So there is a relation between focal length and radius of curvature of the mirror. So focal length is always half that of the radius of curvature, or radius of curvature is 2 times the focal length of the mirror. So if you have a concave or convex mirror, if your focal length is at a distance of 10 centimeter from the pole, then your center of curvature will be at a distance of 20 centimeter from the pole. Radius is always 2 times that of the focal length. The distance of the object from the mirror is called as object distance, is denoted by a letter U. The distance of the image formed from the mirror is called as image distance, and it is denoted by the letter V, and F is the focal length. So this relation gives you, this equation gives you the relation between focal length, object distance and image distance of the mirror, or focal length of the mirror, object distance and image distance. That is 1 upon F is equal to 1 upon U plus 1 upon V. This equation is called as the mirror equation. Then the magnification is the ratio of h dash by h, where h dash is image height and h is object height. So here f is or otherwise you can write this as 2f is equal to r, where f is focal length and r is radius of curvature. So here in this mirror equation, f is focal length, u is object distance and v is image distance. So magnification produced by the mirror is m is equal to h dash by h. Now what is this magnification? It tells you about what is the enlargement or what happens with the size of the image. It is, if you place any object of height 3 centimeter in front of the mirror, when you look at the mirror you can see the image height will be 6 centimeter. When you look at the mirror, the image you found to be 6 centimeter. Then what has happened to the image? It has been enlarged. So by what quantity the enlargement has taken? You have to get the ratio. So m is equal to h dash by h. H dash is image height is 6 centimeter. Object height is 3 centimeter. So you can get magnification is equal to 2. So magnification is equal to 2 means the size of the image has been doubled. The size of the image has been doubled. Instead of that, if you have the object of 6 centimeter, if you place an object, a scale or a pencil of 6 centimeter, and when you look at the mirror, you can see the shortened image, a shortened image of length 3 centimeter. Then what about the magnification value? The magnification will be h dash by h. It is 3 divided by 6. So 3 divided by 6 will be 0.5 or 1 by 2. Zero point 0.5 means half. The image height is reduced to half that of the object size. So magnification gives you what happened with the size of the image, whether the size of the image is increased or decreased, if it is increased by what quantity, or if the size is decreased by what quantity it has been decreased. So if the magnification value is less than 1, you can say image is diminished. If the magnification value is greater than 1, you can say the image is magnified. We'll move on to the next concept, that is refraction of light. So in the previous sessions we studied about the reflection. What is reflection? When light falls on any surface, light falls on any surface, the light bounces back, it goes back in the same medium. Why it is going back to the same medium? So if there is a surface, if the light falls on the surface, instead of propagating further, it is going back. Why it is going back? The surface is not allowing the light to pass through. It stops the path of the light. The surface stops the path of the light and it sends the light back. Suppose if the surface does not stop the path of the light, if the surface allows the light to propagate further, it means the surface is allowing the light to pass through it and continue its journey. Then what happens? Light propagates further into the another medium through the surface. Then this process is called as refraction of light. When light enters into other medium, light enters from one medium to another medium through the surface, then it is called as refraction. But when it is entering from one medium to another medium, the change is going to take place. That is, there is a change in its direction of propagation. So how you can define refraction? The phenomenon of change in the direction of path of light, change in the direction of path of light when it goes from one medium to another medium is called refraction of light. ಒಂದು ಮಾಧ್ಯಮದಿಂದ ಇನ್ನೊಂದು ಮಾಧ್ಯಮಕ್ಕೆ ಬೆಳಕು ಹೋದಾಗ ಅದರ ಪಥದ ದಿಕ್ಕು ಬದಲಾಗ್ತದೆ. There is a change in its direction. Then this phenomenon is called as refraction of light. Then we'll see with the help of this diagram. So this is the surface intermediate of two medium. This is the first medium and this is the second medium. For time being, we'll consider this as air medium and this as glass medium. Just we'll consider like that, air medium and glass medium. Now the ray is traveling in the air medium, So during its journey, it meets the surface of glass. And glass medium allows it to penetrate through it. The glass medium allows the light to pass through it. So then what happens? The light passes into the second medium. Light passes into the second medium. See, when it is entering into the second medium, it is changing its direction. So initially this was the direction of light. When it has entered into the other medium, it has changed its direction. So the ray in the first medium, is called as incident ray. The ray in the second medium is called as refracted ray. So with reference to the diagram, AO is incident ray and OB is refracted ray. Now, with what angle the ray is incident, how the ray is incident, we have to mention in terms of angle. How we have to measure the angle, what should be the reference? With respect to normal to the surface, we always measure the angle. Now, what is normal to the surface? It is a perpendicular line drawn at the point of incidence. At O, if you draw a perpendicular line to the surface, n dash, then n dash is normal to the interface of medium, normal to the surface. Then how we measure the angle of incidence? Angle of incidence is the angle between incident ray and normal to the surface. Incident ray and normal to the surface. This is the angle of incidence. So AON is angle of incidence. How we denote the angle of incidence? By a letter I, angle I. Then the angle between refracted ray and normal to the surface. Angle between refracted ray and normal to the surface. This angle is called as angle of refraction. It is denoted by a letter R. So angle BON is angle of refraction. So here we are considering medium 1 as air medium and medium 2 as glass, or medium 1 as rarer medium or medium 2 as denser medium. So in the next discussion, in the further discussion, we'll see what is a rarer medium and what is denser medium. When we say it is a rarer or denser, for time being, you just observe that when the ray is traveling from rarer to denser, when the ray is traveling from rarer to denser, look at the ray, how it is changing its direction. It is moving towards the normal. It is moving towards the normal, or I value is greater than R. ಅದು ಇದರೊಳಗೆ ಪಾಸ್ ಆಗಿತ್ತು ಅಂದ್ರೆ I is equal to R ಅಂತ ಹೇಳ್ಬೋದಿತ್ತು. ಆದರೆ ಅದು ನಾರ್ಮಲ್ ಕಡೆ ಬೆಂಡ್ ಆಗಿರೋದ್ರಿಂದ ರಿಫ್ರಾಕ್ಷನ್ ಆಂಗಲ್ ಕಡಿಮೆ ಅದ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ಗಿಂತ. ಸೊ I is greater than R when the ray travels from rarer to denser medium. ಒಂದು ವೇಳೆ ಹಿಂಗೆ ಪಾಸ್ ಆಗೋ ಬದಲಿ ಲೈಟು ಈ ಥರ ಪಾಸ್ ಆಗಿತ್ತಪ್ಪ, ಹಿಂಗೆ ಬಂದಿತ್ತು, ಡೆನ್ಸರ್ ಟು ರೇರರ್ ಹೊಂಟಿತ್ತು, ಗ್ಲಾಸ್ದೊಳಗಿಂದ ಹಾಸಿ ಏರ್ ಒಳಗೆ ಹೊಂಟಿತ್ತು ಅಂದ್ರೆ, ಸೊ ದಿಸ್ ಇಸ್ ಅವರ್ ಇನ್ಸಿಡೆಂಟ್ ರೇ ನಾರ್ಮಲ್ ಟು ದ ಸರ್ಫೇಸ್, and this is the original direction of the light, but as it is changing its medium, its direction of propagation changes like this. So this is the angle of refraction. It has been increased. So R is more compared to I when the light is traveling from denser medium to rarer medium. The next discussion will see what is denser medium and rarer medium. So here we discussed about refraction. What is refraction? When the light travels from one medium to another medium, its direction changes, direction of propagation changes. Now along with the direction of propagation, its velocity and wavelength also going to change. The light's velocity and wavelength both are going to change when it travels from one medium to another medium. But in any medium, its frequency is remaining the same. Its frequency is remaining the same. There is a relation between frequency, velocity of light, and wavelength. So it is frequency is velocity divided by wavelength. It is nu is equal to c by lambda. So c changes, velocity of light, wavelength changes. As both change, their ratio is going to remain the same. That is, frequency remains the same when the light travels from one medium to another medium. So there are two laws of refraction. The first law is the incident ray, refracted ray, and normal to the interface. Interface means it is the boundary of two media. The incident ray, refracted ray, and normal to the interface, where we have drawn that normal to the interface at the point of incidence. So these all three lie in the same plane. So this is the first law of refraction. The second law is the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media, and that constant is called as refractive index of the second medium with respect to the first medium. So this statement in the second law statement we can write in a equation form, ratio anupata. So it is the ratio of sine of angle of incidence, sine I angle of incidence, the ratio of sine I divided by angle of refraction, that is sine R. When you get this ratio, it is going to be a constant value for a given pair of media. Given pair of media ಅಂತಂದ್ರೆ ಈಗ ನೀವು ವಾಟರ್ ಏರ್ ಮತ್ತು ಗ್ಲಾಸ್ ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಏರ್ ಆ್ಯಂಡ್ ಗ್ಲಾಸ್ ಇದು ಒಂದು ಪೇರ್ ಆಯ್ತು. ಏರ್ ವಾಟರ್ ಇದು ಒಂದು ಪೇರ್ ಆಯ್ತು. ಏರ್ ಆಯಿಲ್ ಇದು ಒಂದು ಪೇರ್ ಆಯ್ತು. ಸೊ ಇದು ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪೇರಿಗೆ ಅದೇನು ವ್ಯಾಲ್ಯೂ ಬಂದಿರ್ತೈತಲ್ಲ ರೇಷಿಯೋ ಅದು ಕಾನ್ಸ್ಟೆಂಟ್ ಇರ್ತೈತಿ. ಅದು ಮತ್ತು ಬೇರೆ ಪೇರಿಗೆ ಇನ್ನೊಂದು ವ್ಯಾಲ್ಯೂ ಇರ್ತೈತಿ, ಬಟ್ ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾನ್ಸ್ಟೆಂಟ್ ಫಾರ್ ದ್ಯಾಟ್ ಗಿವನ್ ಪೇರ್ ಆಫ್ ಮೀಡಿಯಾ. ಇನ್ನೊಂದು ಪೇರ್ ತೊಗೋಬೋದು ನೀವು, ವಾಟರ್ ಮತ್ತು ಗ್ಲಾಸ್ ಹಿಂಗೂ ಪೇರ್ ತೊಗೋಬೋದು. ಈ ಥರ ನೀವು ಜೋಡಿ ತೊಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಎರಡು ಮೀಡಿಯಮ್, ಆ ಎರಡು ಮೀಡಿಯಮ್ದೊಳಗೆ ಇನ್ಸಿಡೆಂಟ್ ಆ್ಯಂಗಲು ರಿಫ್ರಾಕ್ಟೆಡ್ ಆ್ಯಂಗಲ್ ವ್ಯಾಲ್ಯೂ ಸೈನ್ ಹಾಕಿ ರೇಷಿಯೋ ತೊಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಏನು ವ್ಯಾಲ್ಯೂ ಬರ್ತದೆ? ಕಾನ್ಸ್ಟೆಂಟ್. ದಟ್ ವಿಲ್ ಬಿ ಕಾನ್ಸ್ಟೆಂಟ್, ಆ್ಯಂಡ್ ದಟ್ constant is called as refractive index of the second medium with respect to first medium. Now this equation, the second law of refraction or the second statement or the equation is known as Snell's law. It is Snell's law. Now we'll see what is equal to constant for a given pair of media. Now we'll see what is this refractive index. What is this refractive index? Now before going to that, we'll discuss a special case of refraction. So as we have told, when the light travels from one medium to another medium, its direction of propagation changes. But when the light is incident normally, when the light is incident normally, it enters into the second medium with the same path. It is not going to change its direction. So in that case, for normal incidence, I is equal to 0 and R is equal to 0. So in this case, you cannot apply the Snell's law, because the Snell's law is sin I by sin R. Sin I is sin 0 divided by sin 0. There is no meaning to this equation. It becomes infinity. So normal incidence is the special case of refraction. You cannot apply the Snell's law when the ray is incident normally. Now we'll see what is this refractive index. So at the beginning we discussed that when the light enters from one medium to another medium, its velocity changes. There is a change in the velocity, but by what quantity, by what amount the velocity is going to change, how to get it? That value is given by refractive index. Refractive index tells us what is the change in the velocity, how much is the change in the velocity of light when it is entering from one medium to another medium. So there are two cases, two types of refractive indexes. First one is absolute refractive index, and the second one is relative refractive index. Now absolute refractive index of a medium can be defined as ratio of speed of light in vacuum or air to the speed of light in the medium. Ratio, if you are getting, means it is nothing but you are comparing. So you are comparing the velocity of light in any medium with respect to the velocity of light in air or vacuum. ಅಂದ್ರೆ ಗಾಳಿ ಅಥವಾ ನಿರ್ವಾತದಿಂದ ಬೆಳಕು ಯಾವುದಾದ್ರೂ ಒಂದು ಮಾಧ್ಯಮಕ್ಕೆ ಪ್ರವೇಶ ಮಾಡಿದಾಗ ಅದ್ರ ವೆಲಾಸಿಟಿ ಏನಾಕ್ಕೈತಿ ಅನ್ನೋದು ಕಂಪೇರ್ ಏನು ಮಾಡ್ತೀವಲ್ಲ, ಆ ಕಂಪ್ಯಾರಿಸನ್, ಆ ರೇಷಿಯೋಕ್ಕೆ ನಾವು ಅಬ್ಸಲ್ಯೂಟ್ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ವಿ ಆಲ್ ನೋ ದ್ಯಾಟ್ here you have n is equal to c by v. We all know that c value is velocity of light in air or vacuum. This is velocity of light in medium. Any medium we can take. So here we'll take a glass medium. First one will take glass medium. Another one will take water medium. So light is traveling from air to glass medium. Here light is traveling from air to water. So this is normal to the surface, refracted ray, normal to the surface and refracted ray. Normal to the surface and refracted ray. So there is some velocity of light in air medium. When it enters into the medium, glass medium, its velocity becomes Vg. Here the velocity of light in air is c, velocity of light in water is Vg. Now according to the definition of refractive index, absolute refractive index, n is equal to c by Vg. N is equal to c by Vw, velocity of light in water. So from the calculation we know that Ri of glass is 1.5 and Ri of water is 1.33. So Ri of glass, so glass medium, it is 1.5 is equal to c divided by Vg. Here for water it is 1.33 equal to c divided by Vw. When you cross multiply, 1.5 into Vg is equal to c. 1.33 into Vw is equal to c. It means velocity of light in glass medium, when you multiply that with 1.5, you are going to get velocity of light in air medium. That is, velocity of light in air medium is 1.5 times greater than that of the velocity of light in glass medium. Or else you can write it like this: Vg is C divided by 1.5, or 1.5, 1 divided by 1.5 into C. C, velocity of glass is reduced by 1 divided by 1.5 times that of C. 1 divided by 1.5 times that of C. When you write the same for velocity of light in water, it is VW is C divided by 1.33. So Vg is C divided by 1.5, Vw is C divided by 1.33. So when you compare both of these, where the light is decreasing more, when the ray is entering from air medium to glass medium. So refractive index tells you, absolute refractive index tells you about what happens with the velocity of light when it enters from air to any medium, when it enters from air or vacuum to any medium, or from any medium to air or vacuum. So you are comparing the velocity of light, speed of light in vacuum and in the medium. So in the first case, velocity of glass will be C divided by 1.5. Here there is a more decrease in the velocity. Here there is a more decrease in the velocity compared to the water, because here it is only divided by 1.33. So where there is a more decrease in the velocity, when you compare these two examples, there is a more decrease in the velocity in terms of in case of glass. It means glass is offering more opposition for velocity of light. So then it is called as optically denser medium. So where there is a more opposition for the velocity of light, in that medium is called as optically denser medium. So next concept is relative refractive index. Relative means in comparison. So we are comparing the two media. So here we compared the light, the air and the medium, velocity of light in air and any medium. So in relative refractive index, we are comparing the velocity of light in two medium. So medium 1 has refractive index N1 and medium 2 has refractive index N2. Then N2 is called as N21 is N2 by N1, relative refractive index of second medium with respect to first medium. So here we are comparing the velocity of light in two media. So N2 is absolute refractive index of second medium. So it can be written as C divided by V2. N1 is C divided by V1. So when you simplify the equation, you are going to get V1 by V2. So relative refractive index of second medium with respect to first medium is V1 by V2. You are comparing the velocities of light in both the medium. So N21, when it will be greater, when V1 is greater than V2, N21 will be greater than 1. So when V1 is greater than V2, ಇದು ನ್ಯೂಮರೇಟರ್ ಜಾಸ್ತಿ ಇತ್ತು ಅಂತಂದ್ರೆ N21 ಏನಾಕೈತಿ, ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1 ಆಕೈತಿ. ಸೊ N21 ಯಾವಾಗ ಹೆಚ್ಚಿಗೆ ಇರ್ತೈತಿ ಅವಾಗ ಏನಂತ ಹೇಳ್ತೀವಿ, ಸೆಕೆಂಡ್ ಮೀಡಿಯಮ್ ಇಸ್ ಆಪ್ಟಿಕಲಿ ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್. V1 is greater ಅಂದ್ರೆ ಎರಡನೇ ಮೀಡಿಯಮ್ಕ ಎಂಟರ್ ಆದ ಕೂಡಲೇ ಲೈಟ್ದ ವೆಲಾಸಿಟಿ ಡಿಕ್ರೀಸ್ ಆಗಕತೈತಿ. Here we take again the example of water and glass medium. So here we take water and glass medium. So the ray is traveling from water medium to glass medium. So here is our angle of incidence, angle of refraction. So refractive index of second medium with respect to 1, or refractive index of glass medium with respect to water is N2 by N1. Now N2 is nothing but Ng divided by Nw. Refractive index of glass is 1.5. Absolute refractive index divided by that of water is 1.33. So when you get the ratio 1 divided by 1.5 divided by 1.33, you're going to get the value as 1.127. So N2 by N1 is also nothing but V1 by V2. So when the ratio will be greater than 1, when the numerator is greater than denominator. So in this case we can write V1 is greater than V2. So the velocity of light in first medium in water is greater than in the glass medium. So glass medium ಒಳಗೆ ಬಂದ ಕೂಡಲೇ ಲೈಟದ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗತೈತಿ ಅಂತಂದ್ರೆ ಗ್ಲಾಸು ನೀರಿನಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅಪೋಸಿಷನ್ ಕೊಡಾಕತೈತಿ ವೆಲಾಸಿಟಿ ಆಫ್ ಲೈಟಿಗೆ. ಸೊ ಗ್ಲಾಸ್ ಜಾಸ್ತಿ ಅಪೋಸಿಷನ್ ಕೊಡಾಕತೈತಿ ಅಂತಂದ್ರೆ ಗ್ಲಾಸಿಗೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು, ಆಪ್ಟಿಕಲಿ ಡೆನ್ಸರ್ ಮೀಡಿಯಮ್ ಕಂಪೇರ್ಡ್ ಟು ವಾಟರ್. ವಾಟರ್ನ ಏನಂತ ಕರಿತೀವಿ, ಆಪ್ಟಿಕಲಿ ರೇರರ್ ಮೀಡಿಯಮ್. ಇದನ್ನ ನಾವು ಉಲ್ಟಾ ತಗೊಂಡ್ವಿ ಅಂದ್ರೆ ಒಂದು ವೇಳೆ ಲೈಟ್ ಏನಾರ ಗ್ಲಾಸ್ದಿಂದ ವಾಟರ್ಗೆ ಹೊಂಟಿತ್ತು ಅಂತಂದ್ರೆ, ಗ್ಲಾಸ್ದಿಂದ ವಾಟರ್ಗೆ ಹೊಂಟಿತ್ತು ಅಂದ್ರೆ ದಿಸ್ ಬಿಕಮ್ಸ್ ಅವರ್ ಫಸ್ಟ್ ಮೀಡಿಯಮ್, ದಿಸ್ ಬಿಕಮ್ಸ್ ಅವರ್ ಸೆಕೆಂಡ್ ಮೀಡಿಯಮ್. ಸೊ refractive index of second medium with respect to glass, refractive index of water with respect to glass is Nw divided by Ng. It is 1.33 divided by 1.5. So 1.33 divided by 1.5, the value you are going to get is 0.886. So this in turn will be equal to V2 by V1 when the ratio is less than 1, when the denominator is greater. V2 is greater than V1. So V2 is nothing but our VW is greater than Vg. So here also we are getting the velocity of light in water medium is greater than that of the glass medium. So wherever the velocity ಯಾವುದ್ರದ್ದು ಜಾಸ್ತಿ ಇರ್ತೈತಿ, ಲೈಟದ ವೆಲಾಸಿಟಿ ಯಾವ ಮೀಡಿಯಂ ಒಳಗೆ ಜಾಸ್ತಿ ಇರ್ತೈತಿ ಆ ಮೀಡಿಯಮನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ, ರೇರರ್ ಮೀಡಿಯಂ ಅಂತ ಕರಿತೀವಿ. ಯಾವ ಮೀಡಿಯಂ ಒಳಗೆ ಲೈಟದ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗ್ತೈತಿ ಆ ಮೀಡಿಯಮನ್ನು ನಾವು ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅಂತ ಕರಿತೀವಿ. ಸೊ ರಿಲೇಟಿವ್ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ of any medium is defined as the ratio of velocity of light in a medium. Any medium is defined as velocity of light in any medium with respect to that medium. So refractive index of a medium is defined as the ratio of velocity of light in any medium with respect to that medium. So we note that n is a characteristic of pair of media. ಈ refractive index value ಏನೈತಿ, a pair of media ಆಮೇಲೆ ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಲೈಟ್ ಟ್ರಾವೆಲ್ ಆಗತೈತಿ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತೈತಿ. ನೋಡ್ರಿ ಇಲ್ಲೇ n ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಬಂತು, 1.127 ಬಂತು, ಇಲ್ಲೇ 0.886 ಬಂತು. It depends on the pair of media and from where to where the ray is traveling. So here by looking at the examples, what we can conclude, the medium having higher value of Ri is called optically denser medium, and a medium with lower value of Ri is called optically rarer medium. So from the Snell's law, N21 is nothing but N2 by N1, which is in turn equal to sin I by sin R. Okay, so N21 is equal to N2 by N1, N2 by N1. ಇದು ಎದಕ್ಕೆ ಈಕ್ವಲ್ ಅದ ರೀ? sin I by sin R ಗೆ ಈಕ್ವಲ್ ಅದ. ಒಂದು ವೇಳೆ N2 ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇತ್ತು, N1 ಕಡಿಮೆ ಇತ್ತು ಅಂದ್ರೆ, N2 ವ್ಯಾಲ್ಯೂ N1 ಕಿಂತ ಜಾಸ್ತಿ ಇತ್ತು ಅಂತಂದ್ರೆ ನ್ಯೂಮರೇಟರ್ ವಿಲ್ ಬಿ ಮೋರ್. ಸೊ ವೆನ್ ನ್ಯೂಮರೇಟರ್ ಇಸ್ ಮೋರ್, ಟು ಇಕ್ವೇಟ್ ದಟ್ sin I ಜಾಸ್ತಿ ಇರಬೇಕು. sin I ಜಾಸ್ತಿ ಇರಬೇಕು ಅಂದ್ರೆ I is greater than R. I is greater than R. ಸೊ I is greater than R ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ ನಾವು? I is greater than R ಅಂತ ಯಾವಾಗ ಹೇಳ್ತೀವಿ? rarer to denser ಹೊಂಟಾಗ. I is greater than R ಅಂದ್ರೆ ray towards the normal bend ಆಗಕತ್ತೈತಿ. So when I is greater than R, refracted ray bends towards the normal. So the light is traveling from rarer to denser. ನೋಡ್ರಿ, N2 ಗ್ರೇಟರ್ ಐತಿ ಅಂತಂದ್ರೆ ಆಪ್ಟಿಕಲಿ ಸೆಕೆಂಡ್ ಮೀಡಿಯಂ ಆಪ್ಟಿಕಲಿ ಡೆನ್ಸರ್ ಐತಿ, ಫಸ್ಟ್ ಮೀಡಿಯಂ ಆಪ್ಟಿಕಲಿ ರೇರರ್ ಐತಿ. ಸೊ ರೇರರ್ದಿಂದ ಡೆನ್ಸರ್ಕ ಲೈಟ್ ಹೊಂಟಾಗ ಇಟ್ ಬೆಂಡ್ಸ್ ಟುವರ್ಡ್ಸ್ ದ ನಾರ್ಮಲ್. ಒಂದು ವೇಳೆ ಈ ರೇಷಿಯೋ N2 1 is N2 by N1, again sin I by sin R. ಫಸ್ಟ್ ಮೀಡಿಯಮ್ ಏನಾರ ಡೆನ್ಸರ್ ಇತ್ತು ಅಂದ್ರೆ, ಫಸ್ಟ್ ಮೀಡಿಯಮ್ N1 ಗ್ರೇಟರ್ ಇತ್ತು ಅಂತಂದ್ರೆ, N1 ಗ್ರೇಟರ್ ಇತ್ತು, N2 ಸ್ಮಾಲರ್ ಇತ್ತು ಅಂತಂದ್ರೆ ರೇಷಿಯೋ ಏನಾಕೈತ್ರಿ? ಲೆಸ್ ದೆನ್ 1 ಆಕೈತಿ. ಅಥವಾ N1 ಗ್ರೇಟರ್ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ಇಕ್ವೇಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ R should be greater than I or I is lesser than R. So refracted ray bends away from the normal. ನೋಡಿ, I R ಕಿಂತ ಕಡಿಮೆ ಅದ. ಇದು ಐ ಹಿಂಗೆ ಹೋಗ್ತದೆ ನಮ್ಮ ರೇ, ಆರ್ಕಿಂತ ಕಡಿಮೆ ಐ ಆರ್ಕಿಂತ ಕಡಿಮೆ ಇರ್ತೈತಿ. ಸೊ ದೆನ್ ವಿ ಕ್ಯಾನ್ ಸೇ denser to rarer. When the light is traveling from denser to rarer, the ray bends away from the normal. So here we can also note that the Ri of first medium with respect to second one and Ri of second medium with respect to first one we can relate as N12 is equal to 1 divided by N21. So here we can see N12 is N21 is equal to 1 divided by N12. So 1.127 is equal to 1 divided by 0.886. When you reciprocal it, you are going to get the other one. So N21 is equal to 1 divided by N12. Now another important thing is, when you read the word density, suddenly it comes to your mind that density is mass by volume. Density is mass by volume. But here the optical density, so throughout this discussion we used the word optically denser medium, but here optical density is different from mass density. Mass density ಅಂದ್ರೆ mass divided by volume. So mass density ಅದು ಯಾವುದ್ರ ಮೂಲಕ ನಾವು ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಮಾಸ್ ಮತ್ತು ವಾಲ್ಯೂಮ್ ಆಧಾರದ ಮೇಲೆ ಮಾಸ್ ಡೆನ್ಸಿಟಿ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಆಪ್ಟಿಕಲ್ ಡೆನ್ಸಿಟಿ ಈಸ್ ಡಿಸೈಡೆಡ್ ಬೈ the change in the velocity of light in the medium. Mass density of turpentine is less than that of water. ಅಂದ್ರೆ m divided by v ratio. ರೋ ಏನೈತಿ, ಟರ್ಪೆಂಟೈನ್ದು ನೀರಿನಕ್ಕಿಂತ ಕಡಿಮೆ ಅದ. ಬಟ್ ಟರ್ಪೆಂಟೈನ್ಸ್ ಆಪ್ಟಿಕಲ್ ಡೆನ್ಸಿಟಿ ಈಸ್ ಹೈಯರ್. ನೀರಿಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಟರ್ಪೆಂಟೈನ್ ಆಯಿಲ್ ಇದ್ರದ್ದು ಟರ್ಪೆಂಟೈನದ್ದು ಏನೈತಿ, ಆಪ್ಟಿಕಲ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಐತಿ. ಅಂದ್ರೆ ನೀರಿನಕ್ಕಿಂತ ಟರ್ಪೆಂಟೈನ್ ಏನದಲ್ಲ ಲೈಟ್ ವೆಲಾಸಿಟಿಗೆ ಭಾಳ opposition ಕೊಡ್ತೈತಿ. It gives more opposition for the propagation of light. So this is all about the refractive index and refraction.